This is Geometry, Unit 7, Day 11. We're solving right triangles. We are going to work with the inverse of trigonometric ratios. First topic we want to talk about is what does it mean to solve a right triangle. In the directions on the test and the quiz and the homework, we'll say solve a right triangle. And that means that you're going to find the measures of all the angles and the sides of the triangles that you'll be working with. This idea of an inverse trigonometric ratio. The inverse is what we use to help us calculate angles. So in other words, if you know two sides of a right triangle, then you'll be able to use one of the trigonometric ratios to figure out what the acute angle is, what the measure of the acute angle. So we're going to start with the idea of the sine of an angle equals 0.76. So typically we talk about sine is opposite over hypotenuse. This time, instead of looking at the fraction, we've reduced that and just put it right into a decimal. But still, what angle would have an opposite over hypotenuse of 0.76? So we could take our calculator, and for us to calculate the inverse, which is the -1, sine inverse of 0.76, and that's going to equal the measure of angle A, we need to hit the second or shift key, depending on what your calculator has. Hit sine, and you'll see the sine inverse, sine with a little -1 up in the corner. Typically we need to use parentheses. It won't make a difference with decimals, but it will make a difference with a fraction. And then by hitting enter, assuming that you're in degree mode, it'll show you 49.46. And that's a degree measure, and that's for angle A. So any right triangle that has an opposite over hypotenuse that can be reduced to a decimal of 0.76 must have an acute angle of 49.46. The cosine of B equals 0.17. So cosine means adjacent over hypotenuse. So it's been reduced down to 0.17. So we're going to look at cosine inverse of 0.17 to equal the measure of angle B. So we'll use our calculator and say second cosine or shift cosine. You can use parentheses to 0.17, and that would show us 80.21. Again, that's telling us what the acute angle is if the adjacent side over the hypotenuse can be reduced to the decimal 0.17. If the tangent of an angle equals 0.8, then we would ask tangent inverse of 0.8 to figure out the measure of angle A. Again, tangent inverse of 0.8 gives us 38.66. So what we practiced here is how to plug it into your calculator. So next we're going to look at how can we apply this right to a triangle. This is a right triangle. We know two sides We don't know the acute angles, and we don't know what the hypotenuse is. To calculate the hypotenuse, which is AC, we're looking for that. We're looking for the measure of angle A, and we're also looking for the measure of angle C. To calculate that hypotenuse, we can use the Pythagorean Theorem, something that we had learned weeks ago. It can still apply here because we know two sides of a right triangle. The hypotenuse is c squared. The two legs are 16 and 20. We square those legs. We add those values together. And then we take the square root. And that square root, that would be the exact answer, the square root of 656. If we wanted to see what is the decimal version, you need to know where the square root button is on your calculator of 656, and it's 2561. So it's an approximate, it's not an exact equal sign, because that's a rounded amount. So AC is 2561. Now, for us to figure out the measurement of angle A, let's put a curve marker here with angle A. When we're looking from angle A, we notice that the 16 is considered the opposite side, and this 20 is considered the adjacent side. So, SOHCAHTOA tells us that the opposite over adjacent, we would use tangent. Tangent of angle A, because I don't know what the degree is, tangent of angle A equals the opposite over adjacent, just like we've done in the past. Now we're going to set that over 1. Sorry. There's nothing to solve for. We're trying to solve for the angle, not a side. Okay, so to get the angle by itself, we're going to do the tangent inverse of that fraction equals the measurement of angle A. So bringing our calculator over, tangent inverse, you got to use parentheses with a fraction for sure. 16 divided by 20 gives us 3866. Now that happens to be the same result that we got over here. That's because 16 over 20 is 0.8. So when we did the tangent of 0.8, that's the same thing as doing the tangent of 16 over 20. Tangent inverse. Okay? So now, if angle A is 3866 degrees, to figure out the measurement of angle C, one way you could do it is to know that the two angles are complementary. So to plug in your 3866, the only trouble with that is that if 3866 was incorrect, then you're guaranteed to get the wrong answer for angle C. So we'll take 90 and subtract 3866, and we get 5134. And that is the measurement of angle C. You could also use the tangent inverse of opposite over adjacent from angle C, 20 over 16. Tangent inverse of 20 over 16 would get you that same result. tangent inverse of 20 over 16 would get you that same 51/34. Okay, here we're looking for, when it says to solve for a right triangle, that means to find the missing sides and angles. Well, BC is missing. I don't know what its value is. AC, not sure what its value is. And then the measure of angle B, not sure what its value is. So you're able to solve for any of those pieces first if you wanted. The order doesn't matter. Let's solve for the angle first. So if we're going to solve for this angle, we know that the measure of A and B are complementary. They add up to 90. So if we subtract the 23 from the 90, we're going to get 67 degrees. So that's the measurement of angle B. Now to figure out BC, the segment BC, we notice that that is opposite 23 degrees. And then of course your hypotenuse is across from the 90, and that's our 40. So SOHCAHTOA tells us that opposite over hypotenuse is the sine of the angle, which equals BC over 40. So we cross multiply to solve for BC, and using our calculator we can come up with 1563. Now to figure out the adjacent side, which trig function would we use to figure out the adjacent if we're given the hypotenuse? So cosine of 23 equals the adjacent over the hypotenuse. We put the cosine of 23 over 1 so we can cross multiply. That gives us 40 times the cosine of 23, which equals AC. So now I know that AC is going to equal 3682. On the back side, we're looking at 3 different story problems. This one is talking about building a track for a model train. You want the track to incline from the first level to the second level. It's going to go up 4 inches, and we're going to do this climb over a 96-inch span. So the question is, what angle are we climbing at? They want to know, is the angle of elevation less than 3 degrees? So from the x degrees, we're looking across, which is the opposite side, and right next to the x degrees is considered your adjacent side. So which trig function, when we talk about SOHCAHTOA, the S in SOHCAHTOA stands for sine, and that's opposite over hypotenuse. The C of SOHCAHTOA stands for adjacent over hypotenuse, and the T is for tangent, which is opposite over adjacent. So we have the information of opposite and adjacent. Both the other 2 trig functions require the hypotenuse, and I don't know anything about it. I'm looking for the angle if it has a opposite side of 4 and an adjacent side of 96. So tangent of our x equals 4 over 96. So to get the x by itself, we need to do tangent inverse of 4 over 96 to equal the measurement of angle x. So using our calculator, we'll see that the x is 2.39 degrees. And the question was that less than 3 degrees? Yes, less than 3 degrees. With number 4, a driveway is 25 meters long. It's built on an incline. It has risen a distance of 4 meters by the time it reaches from one end to the other. What is the angle of elevation? So notice this time the information they give us is the opposite side and the hypotenuse. So let's label this A. So from angle A, the opposite and hypotenuse, thinking of SOHCAHTOA, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So sine deals with the opposite hypotenuse concept. So we're going to say sine of angle A, and that should be 4 over 25. So to figure out the angle, we need to do inverse of 4 over 25. That will give us the measurement of angle A. Using our calculator, 9.21 will give us the measurement of angle A. Last one. There's some steps. They rise up 18 centimeters. And the tread, the horizontal piece, the part you step on, is 32. So for us to figure out this angle here, which they're going to call theta, what is the angle of elevation? We could look at the 32, the 32, the 32 and call that 96 all the way down. And a height of 18, 18, and 18. But in this case, what I would suggest is to look at opposite, or what we often call alternate interior angles. It makes that Z shape. So those are alternate interior angles. They have to be congruent. So from our angle here, the opposite side is the 18, the adjacent side is the 32. Be sure not to call the 32 the hypotenuse. It's the adjacent side. It's part that makes the right angle. So opposite and adjacent, that's tangent of this theta angle, which equals the opposite over adjacent. So tangent inverse of 18 over 32 is going to be approximately 2936. So since that's 2936, we know the alternate interior is also 2936 degrees.